Okay, so like I was saying, inverse functions. For there to be an inverse function, it must pass the horizontal line test compared to your function, which were vertical line tests. So a parabola would not have an inverse function because it's got, it touches twice, right? So not an inverse. But what you can do, you can restrict this. So restrict the domain. You can restrict the domain such that it will only have, it will only pass the horizontal line test at one point. So if I had a parabola, I could say, okay, let's just take the positive case, or let's take the negative case. It doesn't really matter. If I say, let's do y equals x squared, for x being only greater than 0, so only the positive bit, well then now this would have a horizontal, this will have an inverse function because it does pass the horizontal line test. So will have inverse now. Okay, so and then to find your inverse functions, all you do is replace to find inverse functions algebraically. You just replace y for x and x for y, and then solve for y. So you replace your x's and y's, and then you essentially solve for y again. So something like this. Determine the equation of the inverse function stating its domain and range. So if I had y equals x minus 1, to find the inverse, all I do is I go x equals to y minus 1, x equals y minus 1, and then you obviously make y the subject again, and the inverse is x plus 1. Your domain and range of your original function. So if your domain was all real x, which it is, and your range is all real y, your domain of your inverse, maybe I should write it like this. I'll probably do a next page with the next questions. Your inverse, your domain of your inverse would be exactly what your range was for your original function. So in this case, it's still all real x. And then your range would be what your domain was for your original function. Again, in this case, it's still all real y. So for the next few, I'm just going to screenshot them and do them on the next page. So here we go. B, I've got the original function as y equals ex plus 2. I like to write that so you guys can see that's original function. Capital F, by the way, not f of x, it's capital F. F of negative 1 is replace x for y. So x equals ey plus 2. Subtract 2. I'm trying to solve for y. How do I get rid of an exponential? You're going to log both sides. Equals log ey, which just becomes y. Log and e just cancels out, for those who are wondering. And then that's your inverse function. What's my domain and range here? Your domain for your exponentials are always all real x. Your range, if you want to draw this up real quick, it's just an exponential shifted up 2. So exponential shifted up 2, that means it'll cut at 3. And your asymptote is at 2, right? Because your asymptote originally is 0, but you're going to shift it up 2. So your range is y must be greater than 2. Any questions at this point in time? Your inverse domain and range is exactly the opposite. So that means my domain was all real x, which means my range is going to be all real y. If my range was y is greater than 2, that means my domain is going to be x is greater than 2. And for those who know how to draw their logs, they know that's true. X can't be 2. You can't do 2 take away 2. You can't log 0. If you try to log 0, it gives you math error. So x must be greater than 2. And then all of your y's work. So if I had to draw that, it'll look like this. We're going to do that next, but it'll just look like this. There is Z2. Shift it to the right 2. And then both the top and bottom work. So all real y. And then x must be greater than 2. Okay. Any questions? All right, C. C is y equals x cubed on 2. Again, that's your original. So your inverse is going to be x equals y cubed on 2. 2x cube root. So the idea is more, I mean, you're not really trying to find your domain range from your inverse. You're more trying to find your domain range from your original function. So your domain is for a cubic, it's all real x, range, it's all real y. So again, obviously for this one, your domain is still going to be all real x, and your range, all real y. Any questions, you guys? Am I going too fast? Stefan, is this making a bit more sense now?
Yeah, it makes sense.
Are you able to explain what's the most important bit of inverse functions?
What do you mean?
The most, like, what's the, like, so if I come up to you and like I mean, you said you've learned it at school, right? And I said, like, what do you know? So you said, oh, I don't know much, but I go and look at my work. Instead of doing that, I'll rather see if you can, you know, commit it to memory. So inverse functions, what do you know? So
I know that the domain and range of the original is just fit when it becomes inverse.
Wait, inverse, great. And then how do I find my inverse?
What do you mean? How do you find your inverse?
How do I
you switch x and y.
Correct, and then you eventually solve for
y.
Y, of course. And then the only other thing is for it to be an inverse function, it must pass the horizontal line. And that's it. And that's pretty much all of inverse functions done for you. If you can just remember those 3 points. D. D is y equals 1 on x minus 2. So again, that's my original function. Before I go any further, I'm just going to write the domain. This is a hyperbola, which means my domain cannot be 2, and my range cannot be 0. It hasn't shifted up or down, so it's still at 0. Yeah, replace it. Yep. And then multiply, and then add by 2. And again, you guys can probably see that is a hyperbola shifted up 2. And then again, what's my domain? Domain would obviously be x cannot equal to 0. You can probably see that. What's your range? Well, it's shifted up 2, so y cannot equal to 2. Or you just know it from this. It's the opposite. All right, any questions about that? Okay, the next thing you need to learn about inverse functions is that they are, they go about y equals x. So there's a rotation there, or there's a flip there, or a mirror, it depends on how you're looking at it, about y equals to x. So what we mean by that, if I had to draw you, for example, the first one that we did, which was x minus 1, if I had to draw y equals x minus 1, it's there. It's always a rotation about y equals to x. So there's y equals to x. And the reason why it's about y equals to x, that's the whole point of why you're substituting y for x and x for y. So when you're changing those letters, you're actually doing this to it, y equals to x. So there's your axis of y equals to x. And if you had to flip that, about that, it will end up where? Just there. Can we all see that? Okay, let's look at another one then. There was an exponential that we did, right? The exponential was at 2. And it looked like that. That's at 3. And we've got y equals to x. And then you're going to flip this about this line. So flip this about this line would look something like that. At 2, if you're going to flip it about this becomes at positive 2. And then flip this about here. So look something like that. I'll show you a computer generated one, so you guys can see all these. There it is. So there's the blue one, there's the inverse. There's your blue one, there's your inverse. About this line, y equals x. There's your blue one, your normal cubic. And then there it is when it's rotated about this. So that one, flip it, will be like that. The blue one, flipped around about this line, will look like this. And that's the only way you're going to be able to draw them. So you're not really going to go ahead and draw some of the hard ones by actually graphing it. You're just going to draw your original and then pretty much flip it about y equals x. So if you ever had to draw your inverse, you draw the original, this one here, the blue, and then flip. So that bit flipped would look like that. This bit flipped would look like this. And again, this bit flipped would look like this. And then of course, this bit flipped would look like this. It gets some getting used to. I can assure you for that. You'll get used to it, but it does take some time to get used to those flippings. Any questions up to that stage? Okay. Find the equation of the resulting curve of these. So I'm going to get you guys doing that for me now. All you're going to do, you're not going to graph, you just got to work out your inverse function. So just replace y for x and solve for y again. So start with the first one, replace it, and then solve for y again. Don't forget, opposite of logs is exponentials, opposite of exponentials are logs. And let me know if you're having any issues. Anyone stuck? I'll do the first one to see. Are you okay with it? Inverse, the inverse function would be x equals log y plus 3. To get rid of a log, I exponential it. And then just take away 3. And that's it. That's A. What are we up to, just so I know how many questions to do?
I'm up to C.
C?
Yeah, right.
D, C, D. Yeah, good, all right.
F.
F.
Oh, we've got a badass here. But F of the inverse, sorry, here we go. X equals, I like it. That was you, wasn't it, Azra? F?
Yep.
Yeah, nice. You have to be. I mean, yeah, you pretty much, yeah, it's required. Y, x equals y, 5 plus 6. X take away 6. And then fifth root. C. F negative 1. X equals root y plus 2. I'll just wait a little bit longer for D, E, and F. D becomes x equals e to the power of 3y minus 4. We plus the 4. We're going to log both sides this time to get rid of the e. And then, of course, divide by 3. Let me know if you want me to go through anything. X equals cube root, so x cubed equals y minus 1, and of course y equals plus 1, and then f. X equals 3 on y plus 4, y plus 4 equals 3 on x minus 4. Okay. Am I waiting on anyone? No, you guys are all good with everything? Fair enough. That should be okay. We'll get to sketching soon. All right, let's look at these ones. Evaluating inverse trig functions. Let me just make sure it's done the same way. So we just did that exercise. Yeah, it has to be done that way. Okay. Maybe some more. All right. All right. Azra, do you know how to actually do like triple I? How to find the exact value of inverse cos of sine pi on 3?
Would you first change the inside?
Yeah, to what?
And you would get your value, which would be sine 60.
True. Okay, yep.
And then you would...
I get it. All right, wait. I just want to see, what about if it was this one? This one.
Would you first do the inside, like similar to the other one, do the inside brackets first?
Okay, do that for me. What do you get? Inverse cos 5 on 13.
It gives 67.38.
Right. And then when you're going to tan it, what's going to happen? Try it. Oh.
2.4.
Worked out. Look, you're lucky that one it worked out again. Some of them might be surds. What I'm trying to say is it doesn't always work out. I'm sure one of these. Yeah, see, I can already tell you, some of them are going to become surds and they just won't work out. So it's a good strategy. I don't know if you'll get full marks for it though. So it's got to be done usually with letting it become like A or something like that. But definitely you're going to get some of them becoming surds. So let's have a look at some of these questions now. Now look, what Azra is doing, which is completely fine. There's no issues about it. Just going and plugging this into your calculator. So sine 60 into your calculator gives you √3 on 2, and then just going inverse cos of that, and the answer just becomes for this 30 degrees, which is pi on 6. Right? There's no issues of doing that, but the problem is it's not always going to be a really nice answer. But if you want it to become an exact, then you probably have to do it with the way I'm about to show it. So let's have a look. What you're going to do is let me screenshot this again. You're going to let your trig identities or your trig values be a particular pronumeral or an angle. So let's say for I, it says find the exact values of inverse tan 1 minus inverse tan 1 on √3. Again, you could have probably subbed that into your calculator and there's no issues about that. The proper way they want it to be done in this part of the topic is inverse tan of 1 is going to be classified as alpha. So you're going to go alpha equals inverse tan of 1. I like using alpha instead of A just because that's usually an angle as well. So anyways, doesn't matter what letter you let it be. Alpha equals inverse tan of 1. And let beta equal to inverse tan 1 on √3. Right, so essentially what you're looking for is alpha minus beta. If that's alpha and that's, okay, do we understand that? Okay, so when I've got alpha equals inverse tan of 1, I can actually tan both sides. So I can bring this back over and I can write tan alpha equals to 1. And I can also write tan beta is equal to 1 on root 3. Are we with me up to that stage? So tan beta equals 1 on root 3. Tan alpha is equal to 1. Now, you've got to think about this in terms of your trig identities. So, and trig values and everything like that. So this alpha minus beta comes from tan alpha minus beta. Tan alpha minus beta. The reason why I'm choosing that is because when I expand this, I actually can get tan alpha minus tan beta on 1 plus tan alpha tan beta. Now from that, I know what tan alpha is. It's 1 minus 1 on root 3 on 1 plus 1 on root 3. And then simplify this. This would become root 3 minus 1 on root 3 plus 1. And then I'm just trying to work out what alpha minus beta is. So if I know tan alpha minus beta is root 3 minus 1 on root 3 plus 1, now you can inverse tan this side to get the answer that we would have got if we had just plugged all this into our calculator in the first place. So it's a little bit annoying, but the problem is 15 degrees. The problem is pi on 12. The problem is that you won't get full marks because they actually want to see it done like this for these questions in extension 1, so that we can tell that you've actually used your trig results. Okay, let's recap that. If you let your first one equal to A or alpha, you let your second one be equal to beta. Then you tan both sides, so you get to this result. Then you look at what you were trying to prove. In this case, it said alpha minus beta. So the only thing you know with tan A and tan B and A minus B is this one here, tan A minus B. There's your formula. And then what's tan A? 1. What's tan B? 1 on root 3. What's tan A? 1. Tan B? 1 on root 3. And then, times it by root 3 minus 1, root 3 plus 1, cancel your root 3's out, and then inverse it, and you're left with A minus B, which equals to pi on 12, 15 degrees. Anyone have any questions for that one? All right, let's do it again. Double I. Double I says inverse sine plus inverse cos, negative 1 on root 2. Inverse cos negative 1 on root 2. Triple I. Inverse cos sine pi on 3. Yeah, look, I'm going to show you triple I first. Hold on. Triple I. Inverse cos of sine pi on 3. Okay, Azra, let me do it with you first, since you've looked a little bit at this before. So let me know when you're there. You're ready.
Yeah.
Yep. All right, look. So the idea isn't really, I mean, of course, we know the answer straight away. You just plug all this into your calculator, right? The problem is you won't be getting full marks because it's not showing that you're working out for this section. Like if it was a 2-unit question, no problems. If it was a extension 1 question, there's a little bit of issues because of in fact that they want to see you guys doing inverse functions properly. So what you're going to do is let the inside be an angle. So you would say sine pi on 3 equals, tell me.
Alpha.
Alpha. All right. So, and pi on 3 is just 60 degrees, right? Let's just put that on the top. for those who are more comfortable with that. All right, equals to alpha. So realistically, what are you actually finding? You're trying to find inverse cos of
Alpha.
Alpha. Okay, just keep that in mind. So what we're trying to find is inverse cos of alpha. Now, with this, sine 60 degrees equals alpha, and then you somehow needed cos. Do you remember what the idea was? If you've got sine and you needed cos, any ideas of how you're going to find that? If I gave you sine theta is equal to something, don't worry what it was, a half here, and I said go find cos theta, what do you need to do? If I said sine theta is a half, how do I find cos theta? Yeah? What do I need to...
Would you have drawn like the triangle?
Yeah, you need to draw a triangle,
the triangle.
Right? So that's the idea. So if I've got sine 60 is equal to alpha, same thing. There's your right angle, there's your 60 degrees, sine 60, opposite over hypotenuse is 1. So the bottom is the square root of 1 minus alpha squared. Why do I feel like I'm making this super hard? All right, hold on. Hold on. Something weird. Find the inverse. No, you've got to do it. I'm not wrong. Inverse cos of sine pi on 3. So I need to find inverse cos of alpha. Cos. Yeah. Let A equal to cos inverse R. Is that what I don't know? Let this whole thing become cos. Is that where my mistake was? Let's see. We said let alpha. What I should have said is this equals to alpha. And then you're going to get sine pi on 3 is equal to cos alpha. And then sine 60 degrees. Yeah, that's too easy. Must be missing something. Maybe it's the other ones that I'm thinking of. Let me look at the next one bits. Because these are inverses. Yeah. I'm thinking of these cases. All right, I'm obviously getting the two different cases confused. So question 1, you can just plug it into your calculator. It's question 2 that you can't plug into your calculator. And it's good to realize the difference now. Question 1, they're inverses on the outside. Question 2, the inverse is in the inside. So the cases I was trying to talk about was more of these ones here. So these ones you can just plug them straight into your calculator. All of question 1 can just be done on the calculator. It's question 2 that can't be done on the calculator. So these ones, all calculator, you just plug them in, there's no problem. It's these ones here that you shouldn't be able to just, well, you're not going to get full marks for just subbing in into your calculator. And I'll show you that with a question like, the problem is all of these are working nicely. I'll find you ones that don't work nicely soon. But let's do question 2. Azra, sorry, back with you. Let's do these ones again, please. But just to clear it up again. Question 1, if inverse is on the outside, plug them into your calculator, no issues. Question 2, trig on the outside only without the inverse, no, there's a problem there. So it's got to be done like this. All right. You can still put them in your calculator, you're just not getting full marks. Just got to get that clear. Azra, you ready? Question 2.
Yeah.
Cos inverse sine 3/5. Okay, go again. So what does alpha equal to? The inside.
Yeah. Sine
which is what?
3/5.
Sine inverse 3/5. Then you're obviously going to sine to this side, so that becomes sine alpha, which equals to 3/5. Then what do you go and do? Because what are we trying to find? We're trying to find cos of what?
Inverse sine.
But that stands for alpha now, right? So we're trying to find cos alpha.
Mm-hmm.
This bit is now alpha. So we're actually finding cos alpha. So if sine alpha is 3/5, now you can go and put alpha there, opposite over hypotenuse. You can work out your bottom one. So therefore cos alpha is equal to adjacent over hypotenuse, which is 4/5. Does that make sense?
Yeah.
Yeah. All right. Thank you. Let's do another one. Double I. Rosemary, let's do this one together, please.
Yeah.
Okay. So you're going to let the inside become an angle. So let alpha equal to inverse tan of 1/2. So again, what are you actually finding now? This now becomes alpha, so what are you actually finding? Sine what? This bit's now this. Rosemary? Might be on mute. Can you hear me?
Yeah. Sorry.
That's okay. What does this become now? So sine of what? What are you actually finding?
Sine alpha.
Yeah, you're actually finding sine alpha. Okay, and then what do you know from this bit? So alpha equals inverse tan of 1/2. You know that means tan alpha equals
1/2.
1/2. Then you go and draw your triangle. There's your half. There's your alpha, sorry. Opposite over adjacent, so 1/2.
2.
Which means this one here is the square root of 2 squared plus 1 squared.
Plus 1 squared, so 3.
Which is
5, yeah.
5 plus. And then that just becomes, for sine, becomes opposite over hypotenuse, which is 1/√5. Yeah, there it is. Azra, can I have you back for a second now?
Yeah.
Watch this. You know, you said plug this into your calculator. It won't work. If you plug this into your calculator, you're never going to get 1/√5. Unless you knew, oh yeah, let's go and square root it. But that doesn't work all the time, because what if this was like this as well?
Mm-hmm.
So that's the proper way of doing it. Does that make sense now? So the calculator business works only if the inverse was in the outside. Okay, Greg, let's do triple Y.
Yep.
tan inverse. It's pretty repetitive. Once you know what you're doing, you're going to let the angle become
Alpha.
Alpha. Then you obviously get 5 on 3 equals.
Yep. Cos alpha.
Then you're obviously going to look for what? What are you actually finding? You're finding tan.
Tan alpha.
Yeah, right. That becomes tan alpha, and then
You draw the thing. It's
adjacent over
3.
hypotenuse.
Yeah.
What? 5 over 3. 3.
Yeah, 5. Yeah, 5.
Adjacent. What? How come the hypotenuse is 3? It's meant to be the longest side. 5 over 13.
Yeah.
There we go. And that, I think, is 12.
Yeah.
And then, of course, tan alpha is
12 on 5.
easy. Easy. Thank you.
All good.
So, yeah, all of these are working nicely because these are numbers that we chose are nice, like 5 and 13. Obviously, if this was, 6 and 13, this would be a different surd. And therefore these numbers would be a little bit different. So this would have worked if you put in your calculator, but like I keep saying, it won't always work. Just keep that in mind. That's the proper way of doing it. IV. Sine 2. Let's do this one with Mariette. Let's do this one together. Sine 2 inverse 2 over 3. Inverse tan 2 on 3. Okay. Let me know when you're ready.
Yep.
All right. What are you going to let alpha equal to?
2 tan, 2 on 3.
I don't think the 2. Ignore the 2.
Tan inverse 2 on 3.
Yep. And then you're going to tan both sides, because if you had a 2 there, you've got to first divide by 2, and then you've got to tan. That's annoying. So just tan both sides.
2 on 3.
And obviously, what are you finding?
Sine 2 alpha.
Which, does that look familiar to you?
Yeah.
What is that?
Double angle where it's like.
Yeah, see? So that's why you would leave the 2 in there. And then again, what's tan alpha? Opposite over adjacent, and then this becomes square root of what? 2 squared plus 3 squared, so 4 plus 9, root 13.
Yeah.
So your answer is 2 times sine opposite over hypotenuse.
13 times
adjacent over hypotenuse. Again, you plugging this into your calculator would have worked nicely only because of the fact that the square roots and stuff all cancelling out. But it won't work all the time. There we go. That's what we want, and that's how you'll get your full marks.
Okay.
Good job. All right, let's go with the next one, V.
Sam, I wasn't finished copying it down.
Sorry. Yeah, I'm just cos inverse sine negative 8 over 17. Cos inverse sine. Cos inverse sine negative 8 on 17. Yep.
Finished, thanks.
Thank you. Let's do Andy. Andy, let's do this next one. You ready?
Yeah.
All right, here we go. So alpha equals inverse sine negative 8 on 17, which means what?
Do the triangle.
Not
Oh
yet.
wait, no.
What?
Sine sine alpha equals to negative 8 on 17.
Okay, now, not only just the triangle, the fact that it's a negative, you've got to also think about this guy as well. So just keep that in mind. What you're solving for is what? Cos alpha. Yeah? All right, here we go. Opposite over hypotenuse. Again, keep in mind the negative you don't include because it's distance. We need to find this shorter side. I'll do that quickly.
15.
Looks like it's 15. Yep. And then sine is negative. So if sine is negative, now I've got to be careful here. Sine is negative. What do we know about tan and about cos? Well, cos will be positive if sine is negative. Sine is negative. Cos is positive. Tan is negative. Should make a point about that. Okay. Andy, what's your final answer for cos alpha?
8 on 17. Oh wait, 15 on 17.
15 on 17.
So how did you know that team was negative?
Yeah, that's what I'm about to say now. So the cos being positive, it's a little bit of a small rule that we haven't exactly looked into, but we can write them all now. Cos of any negative, so works more for these trees. That's probably why I didn't need to write them before. Sine of negative theta. So if you had to sine a negative, this is the same as saying it's negative of sine of the positive. So if you want to try it out, if it's sine negative 20, negative 0.34, it's the same as negative sine 20. Cool. Cos of a negative is actually always a positive. So cos of a negative number is always going to give you a positive cos. Tan of a negative should actually be, so tan negative 60. Yeah, should also be the same as tan, sine, so negative 10. So these two are what we say are odd functions, right? Something that you guys have learned now. These are odd functions, that's why they become negatives of the original. Whereas this guy, cos negative theta, is an even function. Because it's an even function, it gives you back to the original, which means all your negatives are still going to become positive. You with me still, Andy?
Yeah.
Okay. If cos, so now think of this. Inverse, sorry, this bit, this angle is negative, right? Yep. We saw that, sine alpha equals negative. Okay, this bit's negative. What would cos of a negative give you?
Positive cos.
Yeah, that's the problem. So that's the only way I'd realize cos has to be positive.
Okay.
And then you would say sine and tan are going to be negative. So a bit of a tricky one. We might do more of these anyway, so don't worry.
All right.
That's how that works. All right. Maybe some more. If I've finished, I think I've finished for my questions. Yeah. Finding exactly how we can do it. They're pretty much the same. Let's do some textbook questions. I think we might need it. arctan just means inverse, arctan or whatever, arcsine just means inverse sine. So let's do these ones. Okay. But inversing, and that should just be straight in my calculator, right? It's not the ones I'm worried about, it's these ones. In each part, use a right angle triangle, that's the one. That's all we do. So all of these, look, if the inverse is on the outside, you just plug them straight into your calculator. You won't have a problem there. It's these ones here that, and you're lucky in this case, it actually says, you know, in each part you've got to use a right angle triangle, but that's the way it's got to be done. So if your normal one's in the outside, your inverse is in the inside, you've got to use that right angle triangle. And we're going to do that, and hopefully we can get all these negative cases ones right. So 7. Let's do it. All right, Cambridge. Cambridge, question 7, page 83. Okay. Sine inverse cos 3/5. Okay. So all we're going to do now, again, let alpha equals inverse cos 3/5, cos alpha equals 3/5. That means we're looking for sine alpha, because that becomes alpha now. Excuse me, then right angle triangle, that's alpha, opposite, adjacent over hypotenuse, which means this becomes 4. So therefore sine alpha becomes opposite over hypotenuse, 4/5. Okay. Any questions about that one? No. Okay, I can move on. Next, Aya, let's do the next one together. Tan inverse.
Okay, let me write the question.
Tan inverse sine of 5/13.
So we let alpha equal to sine inverse 5/13.
Yep.
And then sine alpha equals to 5/13.
Good. And then
Triangle.
there's your alpha opposite over hypotenuse.
Yeah.
And then you're going to work out this one, which becomes 12. And then what are you looking for? Tan what?
Tan alpha.
Tan alpha.
Which is opposite over adjacent.
Okay. So I think we got these out of the way. Let's do these negative cases. So let's do IV, V, and VI. Let me write them down first. IV. Sine inverse cos -15/17. V cos inverse tan -1/3, and VI. Tan inverse cos of -3/4. Okay. Just to make it clear again, this is cos of a negative is always going to give you cos of a positive. Sine of a negative is going to get you a negative sine, and then tan of a negative is going to be a negative tan. All right, let's see if we can do this. IV. Cos inverse equals negative. So I think you guys get it. If this bit here becomes alpha, therefore I'm just going to write cos alpha equals -15/17. Draw my triangle. That's alpha. Adjacent over hypotenuse. This becomes 8. What you're looking for is sine alpha. Sine alpha is opposite over hypotenuse. But before we conclude that, we just need to check all of our sines. So, all stations to central. Cos is negative here. Now, we're going to be signing. But now, what's inverse cos of negative 5 over negative 15? So, what does inverse cos of this negative number become? Is it a positive or a negative?
Positive.
It's a positive. So therefore sine of a positive is still going to be
Negative.
no, sine of a positive is still going to be positive, isn't it? So wait, Andy, you just said this bit here is positive.
Yeah.
So cos is positive. So sine of a positive is still going to be positive. It was sine of a negative that becomes a negative.
Oh, okay. I see.
So sine of a positive is still positive, which means sine is actually going to be positive.
Yeah.
Which means the only other one is going to be tan, that would have been negative. So the answer would be 8 on 17. And then if you want, check it out on your calculator. Plug this whole thing exactly as you see it with the inverse and the negative in. And if you've done it right, it should still give us 8 over 17. But that's the math of it. That's how you're going to work it out. Does that make sense, Andy?
Yeah.
Can you actually confirm? Plug all this into your calculator. Let's make sure it does give you 8 over 17 and not negative, because then I'm stuffed.
Do I chuck in the negative 15?
Yeah, you're actually going to chuck it in exactly as you see it.
Yeah. 8 on 17.
Yeah. So, V. Cos inverse tan, negative a third. Okay, let's see what happens here. Do you, Andy, just out of curiosity, do you feel like the answer for cos, the final answer, is going to become negative or positive?
It's going to be...
Here, look, cos of a positive, just so you can get this wrapped around your head. Cos of a positive is always positive.
Yeah.
Cos of a negative is always also positive.
So
Cos, think of cos as your x squared.
Oh, so it's always positive no matter what.
No, yes, exactly.
Okay.
Right. Cos is always positive no matter what.
Yeah, that makes sense.
So therefore, this one, tan of a negative is going to be a negative, right?
Yeah.
But then when you're going to cos the negative,
Positive.
it's still going to go back to a positive. So straight away, knowing that it's a cos, you know this answer is going to be a positive regardless.
Yeah. All right.
Cool. All right. Anyways, I'm gonna do it now for you to show you. Where was I? Alpha equals tan inverse negative a third. Again, tan alpha equals negative a third. Again, you do your stations to central. Opposite over adjacent. Opposite over adjacent. That becomes root 10. Again, tan is negative. But I think you guys are seeing if tan is negative, cos of a negative is going to become a positive. So cos is going to become positive there, which means sine would have been negative. And then you're trying to find what? Cos alpha? Cos alpha should equal to adjacent over hypotenuse. So 3 on root 10. Can someone please confirm? Plug this into the calculator. plug 3/√10 into your calculator and just double check that it all works out right. Yep. Anyone confirm it? Is it right?
It's kind of a bit off.
Is it a bit off?
Yeah.
Let me check. 3/√10, 0.948. This one. Cos
It's right.
negative
What are you talking about?
It's right.
Yeah, it's
0.
right.
Yeah, it's right. It does work. How did you get a little bit off?
That's
I think it's right.
Yeah, that's right.
Cos
Yeah.
3/10, yeah?
Cos, yeah, 3/√10.
Yeah.
Just 3/√10. Is 0.948.
Wake up, Andy.
No,
Come on,
I've
wake
got
up.
0.999.
Wake up, bruv. Wake up.
You put 3/√10 and you got 0.999.
Yeah.
Because he put 10
Oh,
and
wait.
he didn't inverse the
You must
No,
10.
have
now I
caused
got
it. Did you cause
0.99.
it?
Yeah, wait.
Oh,
I'm
you
You don't
caused
add the.
it. No,
you add the-
just 3. Yeah, just 3/√10 only.
Oh.
Just this.
Alright.
Just
Yeah.
cause. I see why you saw. I see what you did straight away. 0.99. I got it. All right. Good. VI 10 cos inverse negative 3/4. Okay. 10 inverse cos negative 3/4 should still be, but then that becomes inverse cos. That becomes a negative. Let's cos. Let's have a look at how this one works out. All right. So alpha equals cos negative 3/4. Sorry, inverse cos negative 3/4. Then we're going to cos both sides. So we get cos alpha equals negative 3/4. We're looking for, again, tan alpha. Okay, this time, be careful. All stations to central. Cos is negative. Cos is negative. Now I've got to think about my tan. So this bit here, inverse cos of negative 3/4. This one should be adjacent over hypotenuse. Opposite 4 squared 16, take away 9, 7, root 7. It should be positive or negative sound. Let's call it a negative. What am I missing? 10. 10. Fine. 10 of alpha. Where alpha in this region. Can I avoid that? Can I avoid that anyway? Negative. Where is cos negative? Where is cos negative? Sine and tan. Sorry, where is cos negative? What have I been doing? Why did I draw that? Where is cos negative in sine and in tan? Where is cos negative? Cos negative in sine and tan, which means tan should be negative root 7 on 3. That should work. Let's have a look. Tan inverse cos negative 3 over 4 negative 0.88. Yeah. Where is cos negative in sine and tan? So tan must be negative root 7 over 3. Different logics and cos. Where is tan? Where is tan negative? I should have said sine and cos. I think I've got to look into this a little bit more. I'm definitely convoluting my concepts for some weird reason for these. I have no idea why. Okay. I'm going to leave this one there, but I definitely will come back to this. I think I'm comfortable saying that we're going to leave it there. It's something that I think I really want to go back over again. I'm definitely confusing a few different concepts together. I can see that, and I don't know exactly where it is and what I'm confusing. So let's start the. We're okay with it. It's just I'm not exactly happy to just leave it there. So let's start with the graphs, and then if I get a bit of time, I'm just going to do a little bit of reading and see what I'm mixing up. Okay. Last bit, actually sketching your inverse functions. Inverse functions. So first thing we need to do is learn how they look. There it is. That's exactly what I was just saying. Symmetry properties. Inverse sine of a negative is negative. Inverse tan is a negative. And then for inverse cos, well, that's inverse, but for a cos, it will still be its positive self. Otherwise, for inverse cos, it's odd symmetry. That's fine. We need to know that right now. The graphs. Okay. Inverse trig functions. So, just like any graphs, you've got to learn how each one looks and their domain and ranges. Your normal trig functions go on for ever. Your inverse trig functions don't go on forever, so there's actually a domain and range for them. Inverse sine. Inverse sine should be like that. I'll get the exact numbers out. Again, I'd rather not get anything else wrong. I know inverse cos looks like that, and then inverse tan will look like this. And that should be pi on 2 to negative pi on 2. Okay, let me get you our inverse sine and inverse cos real quick. Inverse trig graphs. Negative 90, so negative pi on 2 to pi on 2, and this one's from 0 to pi. That's all I needed. Okay, so inverse sine looks like this. There's nothing you can do other than just drawing these up right now and committing it to memory. Inverse cos looks like this, and inverse tan looks like this. Your domain for inverse sine is from -1 to 1. Your range for inverse sine is negative pi on 2 to pi on 2. Your domain here is obviously -1 to 1. And your range here is from 0 to pi. Domain here is, there is no domain, it's all real x. Your range from negative pi on 2 to pi on 2, not including pi on 2. Okay. Have we all copied that down?
2 seconds.
Mm-hmm. All good. Still copying? Oh, all good. Okay. So, assuming these have been memorized, we can now start looking into the question. So most of the time the question is just going to be as simple as sketch this function stating its domain and range. The most important bit to learn is how to actually transform your domain and range. So that's what I'm about to do with this next bit here. So you're going to get questions that, for example, will say, maybe even sketch, or for y equals inverse sine of 3x, find its domain and range. So when it's a 3x like this, what happens is your domain of your original case, which was -1 to 1, becomes now -1 to 3x to 1. And then all you do to get your domain, you're obviously going to divide by 3. So it's that simple. So for your domain, if the angles are, tripled or doubled or adding something, you're just going to put that in place of your x and then just solve for x. And that would be your new domain. And if I had to sketch this, you ready for it? Here it is. There's -1/3. There is 1/3. There's -pi on 2. There's pi on 2. It's exactly the same graph, right? It's just your domain's changed. Exactly the same as your normal inverse sine. Okay.
Wait, Sam, are those like, does it stop there, or is it arrows that keep going?
No, it actually stops. Yeah. So,
Okay.
like I said, for these ones, they don't go on forever. Starts here, stops here.
Okay. I think it's just for this.
Okay, no, hold on. Look at them again. These ones started and stopped. Started and stopped. This one goes on forever this way, goes on forever this way. But there's no more on top or on the bottom. That's it. It's limited just to that and that. This just says goes on forever because it's approaching this asymptote. Cool? Does that answer that question? Okay, so what if I had this? Y equals 4 inverse cos 2x. Again, the way I personally do it, I just quickly draw this up. I draw that. I go, okay, this was -1 to 1, 0 to pi. So I memorize my normal one first, right? When I've memorized that, I now know my domain must be from -1 less than or equal to 2x less than or equal to 1, which means my new domain for my inverse function, my new inverse function, this one here, is going to be -1, on 2 and 1 on 2. Now, I also know my range for this. My range is from 0 to pi. But your range is not 4y. So some students think it's 4y. The way it works is you're going to divide by this. So it's got to always be just inverse cos or inverse sine. So it's got to be monic. We've done monic a few times by now. It's got to be monic. So this becomes y on 4 less than or equal to pi. So y divided by 4. That's what you're going to substitute in here. And then, of course, just times by 4. And then, if I had to graph this, here it is. Looks very similar to that, doesn't it? All you've got to just show is your new domain and your new range. Half of that will become 2 pi. Any questions, you guys? No, we're feeling pretty comfortable.
Wait, Sam, why is
Yes.
it 2 pi? Why is it?
Half of 4.
Oh, never mind.
In your normal one, that's okay. I mean, look, in your normal one, 0, 180 degrees,
Oh,
or
it's half.
pi, and then half of pi. I just show that so you can see it's halfway.
Makes sense.
Yeah? Anybody else? Okay. Here we go. You guys are going to start the first one yourself. And then we'll check and see if you get the same thing as me. Does anyone want me to go up for the original graphs again, in case they haven't copied it? No, we're all good. All right, done. Go ahead, do this one. So your domain's not changing. Your range has to be y on 3. Just keep that in mind. And just so you guys are aware, maybe I should emphasize this. This is a typical exam question. I believe you shouldn't do double I until you've done triple I. So my order would be this is first, this would be second, this would be third. Just like we did here. It was a lot easier to do the domain and range then to graph it instead of first to graph it and then go and find your domain and range. It's silly. So when they do that in exams, you'll just do this first, do this second, then do this third. Okay, go ahead. F of 1 just means subbing 1. Is anyone finished? Anyone want to check what they got for I? What did we get? 3 inverse sine 1. Alright, did you get that out? 270 degrees?
Yeah.
It becomes 3 pi on 2.
Yeah.
Yeah, cool. Alright, and then pretty much domain. Have you found your domain yet?
Wait, me?
Yeah.
Oh, -1 less than or equal to x less than or equal to 1.
And then what's your range?
-3 pi over 2 less than or equal to y less than or equal to 3 pi over 2.
That's pretty much it. And then times by 3, times by 3. Easy. And then you just draw your inverse sine. -1, 1, -3 pi over 2, 3 pi over 2. It's more about, with these, it's just more about memorizing the graphs and then just remembering the trick that I just showed you with your domain and range. And then it's really easy, 5 marks. Right? It's like not even a problem. Compare that 5 marks compared to some of the algebraic questions that we were doing in Trig last week. Like these are easier, way easier to get than some of the other stuff. Okay, that looks like it's the same, so let's do this one. Again, instead of drawing the graph, I recommend doing the domain range first. Try that one now. Unless, did anyone have any questions about this? Okay. Question 3. All right, here we go. What do we have? Negative domain, -2 to 2. The range still doesn't change. So there it is. Any questions there? Let's do another one. Let's do, yep, we'll do cos and then we'll do tan and we're done. And then I can always go back over those 3 ones that I'm even having problems with for some weird reason. Inverse cos of 2x. So, do your domain and range for that. Okay. Inverse cos 2x. This one's going to be what, same domain? So it should just be, yep, domain -1/2. Your range is going to be from 0 to pi. And then 0.
Sam, isn't it meant to be from half to... Yeah, okay. Yeah, all good.
Pi and then -1/2. to half. And that becomes 0.12. That's 4 marks. Very easy marks. 10. Okay, domain, still all relaxed. Your range, well, it was going from negative pi on 2 to pi on 2, so now it should be negative pi on, no, 3 pi on 2, right? Because divided by 3 and times that, so 3 pi on 2, to not including y to 3 pi on 2. And then, of course, f of 1, 3 inverse tan 1 should give us 135 degrees. In other words, 3 pi on 4. Okay, all that's good. All right, let me see where I'm going wrong with these ones up here. Inverse sine the original f. Find inverse cos of negative half. That alpha equals inverse cos of negative half. Then cos that where is alpha must be between 0 and 180. Where alpha, hence alpha is in the second quadrant. Y equals means x equals in sine y, so therefore y must be between negative 90 and 90. Y equals inverse cos. Means x equals cos of y must be between 0 and 180. Y equals inverse tan. Means x equals therefore y must be between negative negative 90 to 90. Yeah, we know that, but find inverse cos of negative half. Let a equals inverse cos of negative half. Cos alpha equals negative 90, hence a is in the second quadrant, hence alpha. Cos is negative. It's sine, but you're saying only and the related angle is pi on 3. So So therefore alpha equals 2 pi on 3. Let me think about this. Inverse cos is just not the way I do it. Doesn't really help. A equals inverse cos negative half. Right. That's what I would do. Then I do this. And then are you just telling me all I needed to do, where's cos negative there and there? Sine 10. But the inverse itself only has, the inverse itself only goes from 0 to 180, so therefore it's in the second quadrant, because it can't be in tan. Fine. Okay, let's say inverse tan of negative 1. A equals tan inverse. Hence A is in the fourth quadrant, because from negative 90 to positive 90. The tan also has to be negative, so where is the tan negative in sine and cos? So an angle because of the inverse must be between negative 90 and 90. Is that the extra bit that I'm missing? So that is pi on 4, but that means alpha becomes negative pi on 4. Where is tan negative? Tan is negative in the second and fourth. But because your original inverse can only be from negative 90 to 90, therefore you're picking the fourth. So the second restriction is what I'm missing. Is that what I'm doing wrong? Let's have a look. I think I might have picked up where I was getting some where it was incomplete, my my math. So let's just make sure that A alpha equals inverse sine, yeah. Then sine alpha equals to this. Yes, we said that. But we know that for inverse, your alpha must be between negative 90 to 90. We know that now because of the inverse trig functions we just did. So that means where is sine negative? Sine is negative in tan and in cos. But because it's got to be between negative 90 and 90, which I'll talk about in a second, here and here, therefore it's got to be in the fourth quadrant. Right. And then if you're trying to find tan, wait. That still doesn't make sense. Because you're saying where is sine negative, you would have said tan and cos. Then, and therefore the angle is in the fourth quadrant, of course. Therefore tanning an angle that's in the fourth quadrant will still become negative. Cool. I'm with you. I'm with you. Let's make sure. Sign this one. So therefore that becomes positive, and then where is cos positive? Cos is positive here and here, which means these two must be negatives. And then it's between 0 and 180. So therefore if you were signing it, and if it is between 0 and 180, it's going to be positive. Yeah. Okay. Let's look at this again and see if we can get it out a little bit better second time around. Especially now that we realize I didn't even think you had to use these. Let me see where it is in my booklet. Chapter 2, Chapter 3. Yeah, you probably first have to. I should have taught this first. That's probably where I was getting it mixed up, and that's why I wasn't getting some of them perfectly right. Even though the answers are all right, it's just that I had to look into it a little bit deeper, which. Yeah, these are all positive. Which isn't always the case. You've got to know it from the get-go. So let's have a look at these cases and see if you guys can understand these. So what you've got to remember, firstly, is where your domains work, or so where your ranges work for for these. So same rule as what we were doing before. Inverse cos of negative half, you're letting alpha equal to inverse cos of negative half. Then you get cos alpha equals negative half. All right, then you're asking yourself, I can't draw on this. So what am I going to do for you guys? I'll do it on the other page, but it's like that. Okay. So yeah, we're up to this stage. Cos alpha equals negative half, right? So cos alpha equals negative half. All stations to central. Where is cos negative? We were saying cos is negative here and here. That's where our cos is negative. Now, you know for an inverse cos, so for the original case, so for alpha, which is inverse cos, it must lie between 0 and 180 degrees. So for your inverse cos, it must lie from here to here. So your angle is anywhere in here and here. No, that's not the one I was trying to do. That one's easy. That's not the problem. Sorry. I'm confusing you guys, and I know I'm confusing myself in the process. I'm sorry. It's not that one that I was worried about. It's these ones that we're trying to do. This one here, you just do it the way I've been showing it to you, which is you can't inverse cos a negative, whatever. This one here. Okay, let's go back to this. This has been a mess today. I've got to do it again. Sine inverse negative a fifth. Okay. Again, we're letting alpha equal to inverse sine negative a fifth. And then we get sine alpha equals negative a fifth. All stations to central. Where is sine negative? Sine is negative in tan and in cos, right? So it's in these two regions. You know that your angle for your inverse trig, for your inverse sine, lies between negative 90 to 90 degrees. So it lies somewhere here. And if you're tanning so if you're tanning alpha, of course it's going to be negative. So you're tanning alpha, sorry, no, don't let me get that confused. So you're tanning alpha, your alpha is in here. So you're tanning an angle that's in here. Tan of this angle, tan of an angle that is also negative, is still negative, which is what we wrote before, if you remember that. Tan of a negative gets you negative of the tan of theta, right? So negative theta gets you negative tan theta. So tan of an angle that's here, which is negative, is still going to be negative, which means it'll become, I think you guys can probably see that, tan alpha becomes negative 1 on root 24. How did we get root 24? You draw your triangle, alpha, opposite over hypotenuse, 1 over 5. This becomes root 24. So tan alpha is 1 over root 24, but it's negative 1 over root 24, and then you just rationalize. Who can say they actually get this? Yeah, I didn't think so.
Me. Oh, sorry.
Yeah? You think you think you're getting it?
Yeah.
Fully?
I think it's okay. Yeah, I think it's fine.
Okay. Bit of a bit weird. Let's do it again. Where are we? B. Sine inverse cos inverse cos 4 over 5. Okay, again, let alpha equal to inverse cos 4 over 5. That would mean cos alpha is equal to 4 over 5. And, we do our triangles, everything still stays the same. there. Adjacent, hypotenuse, 25 take away 16 should be, yeah, 3. Okay. Then we're asking ourselves, where is, 2 questions. So the first thing is, where is cos positive? Cos positive here and here. Now for your inverse, where is your inverse cos going to be true? Your inverse cos, y equals inverse cos. Your domain is from 0 to pi, right? So that means it's here and in here. So cos is positive here and here, and if your domain is between here and here, that means sine of an angle that's in here, sine of alpha should be, oh gosh, should be 3 on 5. It should be positive because it's within its own domain. Is that right? Let's have a look. You're saying yes, Greg, and it is right. Oh, that's a mess though. Does anybody else get that?
Yeah, I kind of get it now.
Kinda, yeah. It's not good. It's not perfect. You can't say you're going to walk into your exam and get 100% every single time. It's a bit of a bad one. I might have to take this back and try to see how I'm going to make this one a bit easier for all of us. So I can just see the way I'm saying it, I don't like it. I don't like it, that means you guys definitely hate it. Sine inverse 4/5. Alright, let's try this one again. So we know that sine alpha equals to 4/5. Well, if sine alpha equals to 4/5, then we know this is sine of alpha, which is still 4/5. And in fact, anyways, I don't even know why I bothered doing this. Sine inverse sine, they just cancel out. That just gives you 4/5. True? Sine of inverse sine.
Yeah.
What's the point of even doing that question? Let me see. Yeah. Well, it is now irrelevant. Where this condition is, yeah, that's the only bit that I wasn't including, that condition before. Okay, let's do some more. Let's see if we're going to be good at this. What are these ones? These ones are the tan and then the inverse on the side. So we want to try. Let's try this one. Let's try E. And we'll check the answer to see if we're right. And then I'll probably have to leave it there today. Sine inverse cos root 3 on 2. Okay, so we know that alpha equals to this, which means cos alpha equals root 3 on 2. Then we go and do our all station central, that's alpha. Adjacent, hypotenuse, 4 take away 3 is 1. Okay, so we get that. Then we have to know our all stations to central now. Where is cos positive? Cos is positive here and here, but your inverse cos only works between 0 to 180. Then you're doing sine alpha, and because it's also in here, it's going to keep it positive. So sine alpha should just be 1 on 2. And I'm going to quickly check that.
Yeah.
Sine inverse cos root 3 on 2. Hopefully it gives us a positive half, and it does, and yeah, it is. Okay. All right, next time I'll go through this, and we still have compound angles I realized to do anyways. So we've got one more bit left of trig, and then it's done here.